Hi guys, and welcome to a new episode. Today we'll shed some light and test some light bulbs in order to see if the extra money spent on some of the best bulbs is worth it. A few years ago, a colleague of mine was wondering what bulbs to choose for his car, and I thought, damn, if I would have more free time, I would test this. So, today is the day. First, I'll start with a short overview about the two contenders, after which we'll perform a light output test and a color assessment for each bulb with a comparison between other products on the market. Finally, an endurance test will be performed on the bulb so we can determine which one lasts longer. Let's start. I've chosen two of the highest rated products on the market, which we'll also compare with two cheap alternatives and a xenon bulb. The first is Osram, a German brand now owned by AMS, an Austrian manufacturer. The product that we'll test is the NightBreaker laser, the next generation, and this sounds like it came out of Star Trek. This claims up to 150% brightest increase compared to the minimum legal standard. The lamps provide an up to 150 meter long beam and up to 20% whiter light compared to minimum legal standard. This keeps repeating itself, so keep it in mind. At first I thought that Osram uses a laser to somehow manufacture this filament in a different way, but as it turns out, the laser is used for something else. This is gonna sound so useless, but a laser is used to etch the product name onto the glass in a process known as ablation. That's it. Well, at least they know that any product that has the word laser on it will sell better. The next product is from Philips Lighting, a Dutch company that separated from the main division of Philips and will probably be renamed to Signify. The product that we'll test is called RacingVision, and this also claims 150% more brightness. According to their description, it has an optimized high-precision filament geometry, up to 13 bar high pressure gas filling, high precision chrome coating and high quality UV quartz glass. Now, let's translate all this. Starting with the optimized high precision filament geometry. Two aspects must be considered here that apply to all halogen lamps. The temperature of the filament passes 2000 degrees Celsius during operation. So, in order to have a decent lifetime, a thicker filament must be used. The downside of this is that the light output is smaller. So, to say it simply, a thin filament produces more light, but burns out quicker. A thick filament produces less light, but lasts longer. The optimization part consists of the balance between these two aspects. As for the pressure inside the tube, I'm not sure how relevant is this. All halogen lamps have inert gas and the majority high-quality bulbs are made out of quartz glass. Otherwise, this happens. Halogens are a group of elements in the periodic table and are not the same as noble gases. In these applications, iodine or bromine is used and they prevent the thinning of the tungsten filament and the blackening of the inside of the bulb. I will link an article down in the description if you wish to know more about this. Now let's start with the first test, the light output and color. For the test I use a projector type headlight like we have here. Now, these work a little differently from a reflector type because they use a lens to focus the light on the road. The reflector type uses a mirror to project the light on the surface. Once set, the light output will be measured in lux using a dedicated instrument. Lux is a unit of light measurement where the area is also taken into account. 1 lux equals to 1 lumen per square meter. In other words, the light intensity in a specific area. So, first we'll start with the standard bulb, manufactured by Hella. These are relatively cheap and have good quality. I've decided to include them in order to have a better comparison between these products. For these tests, all lights were off except the headlight, and the camera was set to manual, therefore we have no automatic compensation for the color and brightness. The white balance was set to 4500 Kelvin, shutter at 60, aperture at 5 and ISO at 50. The maximum reading is 603 lux. Now let's test the Osram bulb. From my point of view, there is no visible color difference between the previous bulb and this one, but we'll compare all of them in a moment. The maximum reading is 616 lux, so not a big difference. In fact, I believe that it's so small you can't even tell the difference with your naked eyes. Let's move on to the next product from Philips. Well, as you can see, not a big difference again. Maybe I was expecting a cooler color temperature. The maximum reading is 635 lux. Well, it's better than the previous. Now let's see if a cheap blue tint bulb will make a difference. This has a xenon effect. Well, the color temperature seems the same and the settings on the camera are the same, so I don't know. The maximum reading is 515 lux, so it's the lowest score. Now the last one is the HIDs, also known as xenons. These are rated at 55 watts, so they're a bit more powerful than the normal 35 watts HIDs, and the color temperature is 4300 according to the label. The maximum reading is 912 lux. Wow, now that's intense. No wonder that these are not road legal. Now let's look at the side-by-side comparison. First, the headlight view. If you look very closely at the top three, we can see a slight brightness increase, but the difference is very small. The difference in color is also small, only the Hella bulb has no blue tint. Now let's compare the projected pattern. Between Hella and Osram, we can see a brighter hotspot in the center area for the Osram. Also, in this area we can see that the Philips bulb is the brightest halogen with the coolest color temperature. The cheap Chinese bulb is the worst, with the worst light output, and despite having blue tinted glass, the color temperature is lower even than the Hella bulb. Now let's move on to the endurance test. It's well known that these bulbs burn out quickly, and considering the high price, it's not enjoyable changing the light bulbs every month, to say the least. The main cause for bulb burnout is physical shocks and vibrations. As the filament is incandescent, it gets more susceptible to mechanical stress, which can break it. In order to simulate road damage and potholes which cause the stress, I've made a machine. This has a spinning disc that pushes on the lever, and the bulbs are attached at the end. Also, the bulbs are powered by a 12-watt power supply. And this machine was set to drop the bulbs 3 times a second. Now let's run the time-lapse and see which one lasted longer. I've only tested the bulbs from Hella, Osram and Philips because I accidentally touched the Chinese one and the test would not be fair for that one, even though I'm not sure if this has any influence on the bulb lifetime or not. The first one to go is the Osram bulb, after 2 hours, 5 minutes and 50 seconds. This equals to approximately 22,650 drops. At 2 hours, 21 minutes and 40 seconds, the bulb from Philips also burned out. This equals to approximately 25,500 drops. As for the Hella, I believe that there was a problem with the power supply, because for 5 seconds the bulb lights up very bright, after which it burns out. This looks like the bulb received a higher amount of current after the Philips bulb died, but I'm not sure that this is correct. Now, if we take a look at the data collected from this test, we can clearly see that the Philips won in this episode. It had better light output and had a better lifespan. The regulation for headlights are a bit outdated, taking into account the number of cars that come equipped with LEDs, HIDs and even lasers, and the recent explosion of LED and HID conversion kits available on the market. We need to keep in mind that the claims made by Osram and Philips regarding the light output are based on minimum legal requirements. I'm not sure as I couldn't find this information, but I believe that the legal criteria by which the bulbs are qualified and approved is the wattage. And considering that a few years ago cars using 45-watt bulbs were common, we can clearly see from where the plus 150% figures come from. In my opinion, if the light output is the criteria by which you choose your next replacement, Philips provides a better option, although a 150% increase would surely be more visible from the standard Hella bulb. But in a future episode, we'll test more regular bulbs to have a better idea on the average lifetime of a bulb, and I'm also curious about some 100-watt halogen bulbs. I wonder if this would have a greater light output and by how much. Well, I hope you find this information useful and helpful. If you did, please consider liking and sharing this video so more people can see it. In the next episode, we'll test an oil additive from Metabond. And it was sent by Adrian, so stick around for that. Until next time, thank you very much for watching. I hope to see you soon. Bye bye.